All right, folks, let's pick up where we left off here. Slide deck one, slide number 23, I believe this is. Excuse me. This is slide 23 out of 50. Take a look at it if you want. WAN and LAN are really, and wireless are really the only two terms that I care about, right? Or three terms here. Local area network, wide area network. For the sake of the certification exam, you might be asked, although I highly doubt they're going to ask you to define or compare and contrast metropolitan from personal area networks. Okay. So is this a WAN? Sure is. Okay. Wait, was that it? Okay, sorry, I thought there was another slide to go with this. A wide area network. Geographically, the difference would be if this was 123 Main Street in San Francisco, and they had a separate LAN instead of in Philadelphia, it was on 987 Orchard Street. So same city, but not like relatively close. They'd be a couple miles apart. Anyway. All right, so let's talk about OSI model. I don't like the order in which these slides go, so I'm going to throw an acronym at you straight away. Okay, all people seem, oh, that's supposed to be an S as in Sierra, to need data processing. Okay, so that's a D as in Delta, that is an S as in Sierra. These are the 7 layers of the Open Systems Interconnect model. The order of the layers is important. I highly doubt they're going to ask you specifically to name the layers in order. More specifically, they're going to ask you what stuff runs at each layer. So we're going to touch on that stuff here as well. But application, presentation, session, transport, network, data link, and physical. Those are your 7 layers of the OSI model. Okay, here they are here. This is slide number 26. So yay, we're effectively halfway through the deck now. Okay. From top to bottom, when you are tested on these layers, it is important that you read the way that the question is written. From top to bottom, you're going to spout layers 7 through 1, right? All people seem to need data processing. That's how you'll remember this. If you are asked to label the layers from bottom to top, okay, please do not throw sausage pizza away. Okay, I'm sorry, those 2 acronyms are some of the dumbest I've ever heard, but they've been around for decades, and rather than reinvent the wheel, that is how I memorized these 7 layers in order, right? All people seem to need data processing. Please do not throw sausage pizza away. And here is a graphic of some of the things that run at each layer. Now, later on, we're going to talk about the 4-layer TCP model and how it compresses these 7 layers into 4. But here and now, okay, at the top layers, session through application, these are the items, some of the items that run here. Okay, these are not the only items that run here. Okay, that's a separate discussion and one we'll have later. Okay, your transport layer and your network layer work together. Okay, again, TCP and UDP we're going to talk about ad nauseum later. We're going to talk about IP and some of its, let's call them child protocols. Address Resolution Protocol and the Internet Control Messaging Protocol, ICMP and ARP. And finally, the 2 layers at the bottom, MAC addresses, MAC, Media Access Control addresses, physical addresses, in other words, run here, and your cable, your, let's say media, whether it's cabled or Wi-Fi, runs here at layer 1. So what is this model useful for? Excuse me. The answer to that question, it can take a week. Okay? Back in the day, computers and networks were proprietary. So you would get what we call vendor lock-in. You would buy equipment from Digital Equipment Corporation, DEC, and then you were stuck with them. You couldn't just go out and buy a Windows computer, an Apple, a Linux box, and incorporate it into your network. It didn't work that way. Okay? Companies were allowed to do that because they designed everything, hardware, software, the operating system, how these layers talk to each other, etc. And they were able to lock other vendors out. Okay, not a bad idea if you were IBM back in the 80s. But if you were Compaq in the late 90s or IBM today, that was a terrible idea, right? IBM was the Meta or Facebook back then. And they're still huge today, don't get me wrong, but they are not nearly as big as they once were. Okay, so some very smart people got together and said, listen, this vendor lock-in stuff, this is nonsense. Shouldn't we be designing computers to talk to one another, right? That was the whole premise of the internet to begin with, right? Well, it was a Department of Defense initiative, if I'm being honest, but universities said, hey, wow, we can share research data, right? Even if we have disparate systems, right? We can communicate back and forth, blah, blah, blah. So these folks got together and said, all right, listen, Microsoft, you folks are going to do the operating system stuff. And the folks that write the RFCs for Ethernet, you folks are going to handle this stuff. And the device driver manufacturers for your network interface cards, you're only going to have to, instead of writing code that touches all 7 layers, all I need you to do now is touch these layers. I need you, right, whether it was 3Com or Intel, whomever was making your network interface card, burn a chip onto your circuit board with a MAC address, a permanently static physical address. I also need that NIC to be able to be addressed logically. But the NIC shouldn't have anything to do with the way an email message is formatted, okay, or what protocols email is using. Okay, the NIC shouldn't have anything to do with anything but what does the network interface card need to do? Pick up packets from the source and put them on the network. So really, I need the NIC to be able to do a small subset of these 3 things, and that's it. So the OSI model came to be to break us out of that vendor lock-in issue. And now, right, it's easier for all of us, right? If you're the application, or I'm sorry, if you're the application developer, sure, let's go with that. You just need to focus on that. You don't need to be an expert in TCP or IP or MAC or Ethernet, and vice versa. Okay? Where it helps us as troubleshooters, although this is more like an indirect thing, help desk gets a call. I can't get on the internet. What's the first thing we as troubleshooters try to do? Can I connect remotely to your machine? If I can connect remotely to your machine, that means that your network card is working. That means that you're getting an IP address that I can see. That means whatever I'm using to remotely connect to your machine is functioning. Okay. What if I can't remotely connect to your machine? Well, one or more of these items might not be working. Okay, how do we fix that? Well, there are a number of answers to that question, but here's how I would generally handle it. There's a command we're going to talk about later, ping, P-I-N-G. And ping is a quick test. I'll open an empty suitcase, a packet, and inside that suitcase, I will put a message. Hello, can you hear me? I'll zip up the suitcase. I'll send it to the airport, my network interface card. My NIC acts as the TSA agent, the gate agent, when you're getting on the plane, sends it where it needs to go. Ping allows the recipient computer to open the suitcase, look inside. Hey, look at that nice message. Hello, can you hear me? The destination computer, if it receives the suitcase and is configured to answer hello packets, will do so with a, hi, yes, I can hear you, and it will send that reply. So the first thing I will do as a troubleshooter, I will ask the user sitting at that computer, what is the IP address, the logical address of your machine? And we'll talk about how to get that information. The logical address, I'll ask that user to ping that address. So let's just pretend here that we have a very simple network. And if you don't have a networking background, this may look like gibberish to you. We'll come back to it. 10.0.0.1. These are the period characters on your keyboard. Do not call them periods when you're referring to IP addresses. They're called dots. Nothing like making yourself look like an idiot at a job interview. 10 period, 0 period, 0 period 1. Okay, I, as the interviewer, am going to know right out of the gate, Jesus, dude, you don't know what you're talking about. Thanks for coming. Okay, I don't say dude as a pejorative. That's just like my internal monologue would be like, ugh, whether you're male or female or other. Okay, 10.0.0.1. This is the address in this fictitious example of the computer I'm trying to troubleshoot. Type this command and press enter. Do you get replies to this command? If the answer is yes, that means your NIC and your IP are working. That also means that, well, not quite yet, that your MAC address is working yet. Also, because ping is a TCP packet, we know that transport layer is working. Okay, let's pretend that this worked and it was successful. Yay. Now I need you to ping something other than yourself. So I want you to ping 10.0.0. And let's just pretend the address of the router, the modem to get to the internet is .100. Ping that address. If this 10.0.0.100 returns successful, that means that my switch is working, that my physical addresses, my MAC addresses, which we'll talk about later, are working. Okay, so I've just ruled out the bottom 4 layers. Something else must be wrong. Okay, let's try to ping an address that you visit regularly. Let's just say, I'm going to try to spell Google here. Oh, goodness. Okay, that's supposed to be Google. Ugh. Maybe I should practice writing with my right hand, but I don't know that that would work since I'm using the mouse. Okay, let's ping google.com. So I'm pinging myself. Does my NIC work? Does TCP on my computer work? Yes, it does. I'm pinging the gateway to get to the internet. Does that work? Yes, it does. That means my switch is working, which means layer 2 is working. Can I ping something external to me? Well, that means that this is working. Okay. If I can ping this, now okay, you can get to the internet, but maybe the page you're trying to get to is down. Maybe you spelled Goggle. Maybe you spelled it goggle instead of Google, right? Something stupid like that. Let's see it in action, though, here quick. Okay. Don't worry about this stuff on the screen. I'm trying to work on 100 things at the same time. Here's a command prompt. I get to a command prompt by clicking the start button and typing Charlie Mike Delta. Now, I'm running mine as administrator, meaning I have elevated permissions. Okay, time permitting, we'll talk about that. Okay, first things first. Hey, person calling me, what is your IP address? This 10 dot address here. I need to know that information. We're going to come back to all this other information, okay? But what I want you to focus on right here is that only. 10.0.0.81. Okay, this is my computer's address. So let's see. Can I ping that address? 10.0.0.81. Now, the only way that this will fail is if my firewall, which we'll talk about later, is set to block ping packets, or I fat-fingered the address and typed it wrong, or there's a problem with the network on my computer. Not the network per se, but the network part of my computer itself. Okay, so that works. The next thing I want to try, I want to ping the address of my default gateway. I'm concerned with only this address. We'll come back to this one, 10.0.0.1. Okay, we're going to ping that. Same rule applies. This will work if my computer's network is functional and my router is set up to accept and respond to, hello, can you hear me? Now, the next thing I want to test, right, was ping something outside. Okay. By default, ping packets are hello packets, which ask the question, hello, can you hear me, 4 separate times. On a fully functional network with no other restrictions, I should get 4 replies. Yes, I can customize the number of hellos I send. However many hellos I send, I want exactly that number of replies. It is possible I get fewer than 4, right? I might get 3 replies, or 2 replies, or no replies. I should never get more replies than packets I sent, right? That there's no echo effect here, right? Where I shout, hello, can you hear me, into the chasm? And the response is, yes, I can hear you, right? No. If I send 4, I'm going to get 4 responses, positive responses or negative responses. Okay. This is where else the OSI model can help us. We want to start our troubleshooting at the most common possible problem, which is here. If I can't ping any of these things, have you tried restarting your computer just for the heck of it? Maybe Windows did an update which updated your driver for your network interface card, and a reboot is pending. Maybe the cable that connects your computer to the wall jack, not the power cable, but the Ethernet network cable, maybe it's loose or broken. Maybe it fell out of the jack. We're going to start troubleshooting here first. We're not going to run to the data center and start looking at the $10,000 core switches. That's not where we're going to start. Right? We're going to turn your computer around. We're going to look at what we call the link lights on your NIC. And I wish I would have thought of it earlier. I would show you a quick graphic of what that looks like. And we'll troubleshoot from the bottom up. Okay? If everything else about the internet works, I can send emails. I can browse to Yahoo Mail. But my SAP application to the cloud fails. Well, that might mean that the internet is running, but SAP's connection might be down, right? So we're not going to start with that premise. We're going to start down here. We're going to look at people kick cables all the time. People step on them, they trip over them, they disconnect them, and they plug them back in incorrectly, right? So that's where OSI can help us. Okay. Want to do some more reading? There you go. Wikipedia has a long and detailed description of each layer. So slides 27, 28, and 29 for your perusal. Okay. So a little more detail. Okay. I have to be careful how I say this. Layer 7 is called the application layer, but it doesn't deal with just applications, right? Microsoft Outlook is an application that uses the OSI model, but does Microsoft Outlook run in the application layer? Well, some of it does, yes. Not all of it, though, right? So don't be fooled into thinking, Google Chrome is an internet or is an application on my computer. It runs strictly at no, it doesn't. Okay? It's a little more complex than that. Okay, here's the dictionary definition. Okay, your browser, sure, and SNMP, which a lot of my peers use to gather inventory information and troubleshooting information from their networks. Presentation layer involves encryption, right? So not only how is my email message packaged, but is it encrypted? And if so, how is it encrypted? Okay. Many networks require that data being sent across the wire is compressed. Okay. So let me give you an example, a simple example if I can. The maximum size of an Ethernet suitcase or Ethernet packet is 1,518 bytes. You'll hear administrators say it's 1,500 bytes. Okay, we all know what you mean when you say that. Technically, it's 1,518 bytes. Now, those of you who have a networking background, you know about large packets and things like that. I'm not talking about any of that stuff yet. I'm talking about just the default plain Jane right out of the box. Let's say that I'm sending you an email with an attachment. And the total size of the email, including the attachment, let's do this just for math, to make the math easier. The total size of this packet is 15,180 bytes, or 15 kilobytes. 15K, capital B. Capital B is short for bytes, right? Oops, oh my God, spelled this way. That's supposed to be an E. Great, all right. So I'm going to say something to you, and it might seem counterintuitive, but here it comes. How many packets do I need to send you a message this size if the maximum packet size is that? Well, the answer would obviously be 10, but it's not always 10. Packets have to include other information than just your payload. The payload in this case is the email I'm sending you. The packets have to include the source address, the destination address, the protocols being used, and other information. So this email that's that size, while the payload fits nicely into 10 packets, requires more than 10 packets because of the overhead associated with Ethernet and TCP networks. However, because compression can and does happen, I might be able to get back to just 10 packets. Okay. Now, again, the only reason I'm bringing this up now, one, I don't want to forget to tell you this later because it will be important later. Two, if you would happen to be asked a question this, air quote, silly on the exam, know that without compression, the default answer will be 11 or 12 packets, not 10. because of the overhead. Okay, we'll see some examples of that moving forward. And the session layer is responsible for starting up, maintaining, and terminating sessions between sender and receiver. I'm not just talking about email. You're watching this video on your own computer connected to a browser. There's a session between your computer and the server hosting these videos. That session is maintained by the session layer. The session layer is responsible for other items as well. I'm going to super simplify this. You go to Amazon and you are shopping and you add things to your cart. So you add 3 widgets to your cart, but you're not done shopping yet. So you go out and you're looking for widget extenders. While you're searching for widget extenders, the 3 widgets you have in your cart stay there. Now that's a different kind of session. That's a web or application session, but the concept is the same, right? Just because I'm over here doing other things, looking for these widget extenders, the session layer as it relates to OSI keeps in mind my connection to the shopping cart that I set up originally, right? If that makes sense. Okay. If it doesn't make sense, that's okay. We're going to delve more deeply into these topics as we move. Okay. Transport layer. How does data get from A to B? Well, you've got 2 choices. Well, you have 102 choices, but the 2 primary choices are transmission control protocol versus user datagram protocol. We have to hammer the stuffing out of this, but here and now, TCP is slower, but more reliable. TCP is a connection-oriented program, meaning you and I are having a conversation, and I say something to you. Then you have to acknowledge that you heard what I said, so you answer me. That is a connection-oriented communication. I say something and you respond. UDP, I'm over here having a conversation with you. You're out there watching Netflix. Maybe you heard half of what I said. You don't reply to any of it. I don't know. Did you hear none of it, some of it, or all of it? No idea. This is called connectionless oriented. I say what I'm saying, and you hear it or you don't. Right? That's not my problem anymore. Once it leaves my lips to your ears, that's now on you. Okay? So we'll come back to that. Okay? Another term I need you to become familiar with is encapsulation. Let me see if I can draw this out a little bit. Okay? So I'm going to send you an email. And the email is contained in this rectangle. I hit the send button after I type your name into the to field. The application layer gets it. The application layer says, aha, this is an email from Mike to, whomever you are. The application layer, layer 7, adds a little header. This is encapsulation. The application layer opens the suitcase, adds its own information, says to the presentation layer, layer 6, hey, I'm finished with my part. Layer 6, here you go. The presentation layer looks inside, says, this is an email. I see that the application layer has added its header. I'm going to add my header. That's supposed to be a number 6. Number 5, right? The session layer. Okay. The act of encapsulation is each subsequent layer adding its, hey, I looked at this, here's my part of the work. And after you're finished, right, you're going to have, this is why the 15,180 byte email doesn't fit evenly into 10 packets. You're going to have 6 headers. The physical layer is not going to add its own header. You're also going to have a footer here at the end. This is your email originally. Whoa, okay. that email now has to get broken up into even more chunks. And each chunk gets these 6, 7 additional items. When your computer gets the email, your computer de-encapsulates it, opens the suitcase, makes sure, hey, layer 2, okay, we're good. Layer 3, did you do, okay, we're good here. Layer 4, we're good here, right? And then eventually, all that your computer is left with is the 12 packets of my email. There will be a sequence number, and your computer will use that sequence number to put these packets back in the correct order. Encapsulation versus decapsulation. Okay, the network layer is where logical addresses happen. Logical. I'm just going to type the letter L there instead of trying to spell the whole thing. Logical addresses are IP addresses. Okay? There are billions of IP addresses in IP version 4. IP version 6, I believe that number is in the maybe hundreds of billions, it might even be trillions of possible addresses. Okay, we'll talk more about you'll be sick of hearing me say IP address till this semester's over. Data link, this is where physical addresses, or MAC, M-A-C, media access control addresses reside. And layer 1, okay, is it fiber optic cabling? Okay, we need to understand the communication mechanism of fiber. Is it Ethernet? Okay, is it Cat 3, Cat 5, Cat 6, Cat 7 cable, whatever? Is it Wi-Fi? What channel are you on? You know, what SSID are you connected to? That kind of thing. All right, what time is it? Give me 1 second. Okay, I have a standing call I have to get to here shortly, so let me get as far as I can. Okay. Another acronym you'll hear us use quite frequently is PDU. Now, I just call them packets. Technically, that isn't correct, right? There are packets and segments and frames and bits and PDUs. And once you get into the networking weeds, they all mean something a little different. From our perspective here, this is an introductory level exam. I'll use the term PDU or packet interchangeably. There's no problem here in doing so. Okay. A PDU is just a group of data that move from layer 7 to layer 6 on the sending machine, move from layer 1 to layer 2 on the receiving machine. That's it. Okay. So here's a much better graphical representation. Okay. Notice the payload, right? My email. Yeah. Okay, the data link layer adds its trailer. The recipient machine gets it and starts stripping away all this stuff. Okay. Notice the size of the frame here versus the size of the payload. Well, geez. Now, if this payload was larger, like my 15K email, that payload would have to be cut to fit, because the entirety of the frame is limited to 1,500 bytes. That's it. Unless you're using large packets, which we haven't talked about yet. Okay, I just said that, the data link layer. That's slide 39 and 40. That is a question you might see on a quiz or a test. I can see that. All right, so we have only 10 slides to go, and then we're finished. And then I'll stop there, even though we'll come in at less than an hour. Safety procedures. Oh, okay. I'm going to say this, although it may not be in these slides. When I was learning A+, because the A+ exam was the first certification exam I ever took in 1999, whatever year it was. It's been a long time. I took the exam before they introduced the 3-year expiration. So technically, I am grandfathered in, which is funny because I'm old enough to be a grandfather. But I haven't built a PC for someone in a decade. I think the last person I built a PC for was myself. About 10 years ago, I built myself a gaming computer, which I thought was a neat project. But then I thought, what the heck am I doing? Okay, I'm at the point in my career where my eyes aren't that good, and my hand-eye coordination and my dexterity aren't the best. What the heck? If I need to replace this computer, I'm going to buy a gaming computer and I'm going to let somebody else put it together for me. But what I'm trying to say here, and I don't recall if this is in these slides, the anti-static straps. Now, I learned two things working with anti-static straps when I was studying for A+. One, you wear them all the time when you're working on a PC or a laptop or a server. They're going to drain the static electricity out of your body because, believe it or not, right, I don't know if you've ever worn like fuzzy socks and you've shuffled your feet across like a shag carpet and then you run up and touch your buddy and you get that little zap. The things that we used to do for entertainment pre-internet. That type of shock will bugger up a motherboard. You just spent $2,000 on that NVIDIA GTX graphics card, and bzz, what's that smell? Oh, that smell is you pissing away $2,000 because you just burnt the board with a static shock. Okay, so a static wrist strap, good idea. Where you don't want to wear a static wrist strap is if you happen to be working on TVs. Now, I don't know if any of you are old enough to remember CRT monitors, but anything that has large capacitors in it, for the love of God, do not wear a static strap and be working anywhere in the vicinity of large capacitors. If you've ever seen the inside of something electronic, they look like little soup cans. Now, I say little. They obviously come in various sizes, but the capacitors in a PC's power supply, a server's power supply, a CRT monitor can kill you. And the wrist strap actually acts as a conductor of that jolt from the board into your body. Okay, now I don't know anybody who suffered serious harm, but I've read a number of stories about that, right? So even if these slides don't say it, okay, if it has large capacitors in it, take that damn strap off and, put it far, far away. Okay, do I have to tell you about emergency exit signs? And some data centers you work in may have a halon system. Oh, there's a fire. You press the button and this gas is released from the roof. It's called halon gas. Halon gas works, and I'll simplify it, by being heavier than oxygen. So it comes from the ceiling, lays on top of the oxygen, and the weight of it pushes the oxygen out of the room. That's a great idea to put out a fire because fires need oxygen to burn. If you happen to be locked in the server room when that goes off, okay, you do know where the emergency power off switch is, right? I hope you can find it and hit it before you choke to death. I'm not saying that facetiously. Okay, halon systems, you want to be very careful of those. Always know how to get out of a confined space like that. Always know whether or not you have a power off switch and where it is. Okay, OSHA. Okay, we'll talk about OSHA if we have to. Lifting heavy objects. The general rule of thumb at places I've worked with previously is 50 pounds. The expectation is I should be able to lift 40 to 50 pounds on occasion with or without the use of assistance. Now, assistance can come in the form of you're going to help me by grabbing one end while I grab the other, or maybe like a hand truck, or, a little cart on wheels, that kind of stuff. I remember I had a job where I would rack mount servers. And some of the servers I worked with back in the day, depending on their configurations, they could weigh 60 to 100 pounds. And it was just me. And I would sit crisscross applesauce on the floor when I was able to do that. And I would cross my ankles and I would balance the server on my knees if the rack I was putting it in, the opening was at the bottom, because then I can kind of like, squeeze my legs together, which would lift my knees a little bit or relax a little bit. And then I could use my hands to try to align the server. For openings that were a little bit higher, I'd sit crisscross on the floor. I'd balance the server on my head. That's not a joke. I've cut myself a number of times because the bottoms of servers, they have these little rivets and things like that. And if you're not careful, but again, like if the server weighs 100 pounds and there's nobody else around to help me, and my boss didn't spend the money to buy me like, one of those back braces or whatever, you gotta get done what you gotta get done. Okay. The OSHA regulations, like if an OSHA inspector would have walked in while I had that thing balanced on my head, my boss would have been taken out back and beaten with a rubber hose. Okay. But again, you do what you have to do to get the job done. Okay. I can tell you from experience, I've had a number of back and neck surgeries. You lift with your legs and not with your back. And that's easy to forget. If you have to ask for assistance, you ask for assistance. I remember being young and invulnerable and immortal, and nothing could hurt me, right? And when I did get hurt, because I was young and generally fit, I'd recover pretty quickly. But I'll be 56 years old in March. Okay? I can sneeze too hard, and my neck hurts the rest of the day. I'm not kidding. This is what happens when you get older, right? So take care of your body while it's young. Not just because OSHA says to do it that way, but because if you live to get old, you don't want to be falling apart at the seams because you used to do stupid things like carry a 100-pound server and rest it on your forehead while you're trying to balance it and get it into a rack. Okay. Grounding. Okay, there we are. The ESD straps, electrostatic discharge. All right. And this is it. We've got like 3 slides to go, and then I have to bug out because I have this call. How do you troubleshoot problems? Here's what's last on the list, and I'm going to tell you, in my opinion, this is the most important thing. We have what we call Kbs, knowledge bases. Now, some administrators call them other things. My peers and I, we call them Kbs. Microsoft calls them Kbs, which is where the habit came from. I fix an issue where widget A lost communication to widget B today, but I don't write it down. Next week, I'm on vacation. Widget A loses communication with widget B again. If I don't write down what I did, now you get tasked with fixing it. Guess what you have to do? You have to start over again. Now, if the person calling in the issue is the same person as last week, that person gets mad at you. Why is it taking so long? Mike solved this for me last week. And your answer to yourself, because you don't want to say this out loud, well, Mike's an idiot. He didn't write it down, so I don't know what the problem is. Now, next thing you know, the person who calls it in calls your boss, who calls you, and now you and me and our boss, we have to have a meeting. Mike, why are you a doofus? Why didn't you write this down? Always document the things that you tried and failed, and the things that you tried and were successful. Always, where you can, use change control. Microsoft has Patch Tuesday every month. You want to get permission from your change control board to roll out these patches. Oh my God, Microsoft's patches in November and December. I don't have enough fingers and toes to count the number of issues that these patches caused for some of our largest customers. RC4 encryption broke. Printing broke. Kerberos broke. Trusts between the Mike Kelly domain and the L-Tri-C domain broke. Oh my God, we got to go through all the... Yes, you do. Internally at Microsoft, we had 100 meetings discussing what happened, why did it happen, why didn't we figure this out before we rolled these patches out to everybody, how are we going to fix it, blah, blah, blah. Okay. But while you're new to this, is it just you that's having the issue? Or is the internet down for everybody? Oh, okay, it's just you. All right, maybe your computer needs to be rebooted. If everybody's having the issue, oh, maybe my cable modem needs to be rebooted. Maybe I need to call Comcast. Maybe the internet to my building is down. Okay? You're not going to call Comcast if one of your users is down. Is that user on a desktop or a laptop? Are you connected to a docking station? Are you connected to wired or wireless networks? Okay, you don't know what you don't know if you are new to this field. But don't be afraid to ask a general question. One of the things I love to do if I'm working with newer technicians is I'll explain to you every step of my thought process. Each individual problem we run up against. I'll tell you why I think it's probably item C, but not items A and B. Well, because in the past, items A and B, blah, 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 and I'll have an explanation. And you take notes if you want. Hopefully you do, right? My mentor, when I was very young, I'm not kidding, he said to me one day, as long as I'm the only guy who knows how to do things, they can never fire me. Which is BS, by the way. He quit. I got promoted into his position de facto because they wanted to reduce headcount anyway. I don't have the passwords to anything. I can't log into anything. It takes me 3 times as long to fix anything. So way back in 1997, 98, whatever year it was, I said, I'm never going to treat somebody like that, right? If I survive in this career long enough to become a senior technician, I'm going to make sure that I don't ever put anybody in that position. 1, I hated it when I was the junior tech. 2, selfishly, I want to be able to go on vacation. I want to hang out at the beach. I don't want my phone ringing 10 times a day because I didn't tell you when widget A loses connectivity to widget B, look at items A, B, and C, but start with C because that's usually what it is. I want you to know that stuff. Okay? So that's a whole 10-minute spiel on troubleshooting without me reading to you from the slide. Okay? I call this trial and error. Much more error than trial, especially early on in your career. But you'll build up your own internal knowledge base as you get more experienced. Okay? And these are questions you can answer if you want. And that's the summary, and we will call it. All right, so wow, land speed record for me. All right, thanks for your attention. That's the end of slide deck number 1. I will talk to you all next time.